Okay, this is going to be phase 3 out of 3 with our inheritance lecture series. We are specifically concentrating on what it means to have polymorphic behavior. We'll look at that definition, and then we'll look at a couple sets of classes. And so the main part of this document repeats what you've already had. It puts it all together in one document, and I'm just going to scroll to the very middle of it, where the topic name is polymorphism, right there. And I have a couple things bolded in red right up there, and I have some highlighted phrases down below, and that's all I'm going to call out in addition to you reading this. So we see what's up here in red. Several of you have asked still, why do we have this hierarchy? And I'm just going to kind of go over this, what's in red, again, to provide the reason. Inheritance provides a common base data type that lets us refer to objects of specific types through more generic types of references. And what that means is that the sets of classes have a relationship that we want to honor, that we think is a good idea in its design, and we want to enable, like we've talked about in class, a generic type of reference, a shape reference, and that it manifests itself in a specific type of object. After you've read the other couple items, I'm going to emphasize these things that I have highlighted in the PDF file. We will need to know what is meant by dynamic binding or late binding. We will also need to know the very specific definition of polymorphism. And so what I'm going to say is, if you were to ask me to define polymorphism, I would do it right here. And I would do it in this manner. Polymorphism is the process during runtime in which the appropriate method implementation is chosen based on the actual type. What we've already talked about in class is if you have a shape that is instantiated as a wheel and you ask a wheel to draw, it will during runtime use the wheels draw method instead of the shapes. It's important that polymorphism happens during runtime, which is why it is called, why it has an association with dynamic binding. Okay, so that's what those mean. Now let me bring in the two pieces of code that you have online. And the first one that I'm going to bring in is this one with, it has a bunch of different classes. So it has a driver, which I'll talk about in detail. But this particular series of classes is just like we've already talked about. It has a shape interface. It has an intermediary abstract shape class that is partially implemented, and then it has a circle, a rect, and a wheel. So what's different about this is that there's some new terminology shown in this particular driver. And the new terminology at the very beginning is this instance of keyword. So you can see that it's blue. And the thing that always really bothered me about instance of is that it didn't have the O of capitalized. So every time that I would try to use instance of, it would be a syntax error. Okay, so it kind of goes against other parts of their standards. But in any case, you can see that it turns blue, so you know that it is the correct reserved word to use. And so basically what instance of means is you have, let me go back just a little bit, you have an array of shapes, and in this for loop you spin through the 10 element array, and depending on if it's mod 3 is 0, 1, or 2, you make a circle, a rectangle, a rect, or a wheel. And since shapelist, this is shapelist, since shapelist could be any of these, it contains shape references, as we've discussed, we want to know, is this particular object instantiated as a wheel? And that's how you use instance of. There's no other commas or semicolons or colons or anything like that. You grab the object that you're talking about, you put instance of in the middle, and then you ask, is it a wheel? Okay, so that's how we do that. So if it's a wheel, we want it to draw. And what the important parts on this part of the code is casting or not casting. All right, and sometimes you must cast and sometimes you don't need to cast. This particular one, shape list of J, is a shape reference. Okay, it was instantiated as a wheel, but that doesn't mean it is a wheel. Set spokes is a method that is very specific to only the wheel class. So a shape, which shape list of J is a shape reference, doesn't know how to set spokes. So we grab shape list of J, we cast it as a wheel, like we know how to cast it, and we ask this, you can see the parentheses, how it's grouped, we ask this to call a method set spokes that is available only in wheel. So since set spokes was not in the shape class, there's no set spokes here, and it doesn't even make sense for that to be there, we must cast it. We do not need to cast this particular line because this illustrates polymorphism. We say shape list of J, which is a shape reference, go draw yourself. We have no problem with that because in the shape interface, draw is declared. Therefore, we can have a shape be asked to draw, like we've illustrated in class. Let's go down and talk a little bit more about different casting or not casting. When do you have to? When is it optional? So we scoot to the end of this class, and you can see I have lots of comments right here. So we'll explore this. So what we could do is different than we did up above, up here. We could cast this. This is a completely different statement now. We're not in that loop. Could we ask shape list of 4 to draw itself after casting it as a rectangle? And the answer is yes. So up here, if you look at in the for loop, 4 mod 3 is 1, right? And so it was supposed to be a rectangle. Okay, so it is a rectangle. We could have checked with instance of, but we didn't need to because we looked at the code. This is okay to cast. You can cast when you don't have to cast, and it's not going to be a syntax error. Okay. This is fine because it's exactly the same example as it was up above. Shape list of 4, we ask it to draw. Shape list of 4 is a shape. We reach up and see that its draw is declared. It's a rectangle, so it draws like a rectangle. Works just fine. What you can do, just skipping this, I'll come back to that in a minute. What you also can do is you can declare a wheel as a circle. Okay, a wheel is a circle. I have it uppercase here. Okay, to contrast with this is not a. So a wheel is a circle. So you can do the same casting idea as I did up above. Okay, so what we're doing here is we are casting this wheel as a circle, and it will just draw the circle. Okay, so we're forcing it to draw as a circle. What you cannot do is you cannot do this. You cannot take a more general class and assign it to a more specific class. You ask yourself, is a circle is a wheel? And you say, well, it could be, but it doesn't have to be a wheel. Okay, so this would give you a syntax error. Okay, let me bring in the other code, the final code that I want to talk about in this movie, and just show you one thing. This is also available. This is a different set of classes. This shape is the same interface, but I just wanted to show you that you could have a circle that directly implements the interface. You don't have to have that abstract class step in between. So circle implements shape, and so does rect implement shape. That means the same thing that it did for the other inheritance. It means that it looks at this shape interface and it knows that it has to define all of these, and it can also define more if you would like. Okay. So what I'd like to show you about this, knowing this hierarchy of the shapes, is an error that just kind of seems weird. I have an array of rects. Okay, so that's that. And I do different things. And this code is definitely worth looking at. But what I want you to look at is the error that I do if I comment out this right here. Okay. If I uncomment out this. Shape list is an array of shapes, 5 elements up there. Okay. We have made a circle for shapelist 0, a rect for shapelist 1. Here for shapelist 3, we try to make a new shape. And now you know that you can't make a new shape because you know that a shape is an interface, and an interface cannot be instantiated. Okay. But here's the thing that's a little bit weird. When I run this, the error is something that's a little bit unexpected. So let me compile it. Sorry, not run, compile. It says shape is abstract, cannot be instantiated. It does not mean that shape is an abstract class. It just means shape is abstract in the sense that it is unfinished. So abstract is a keyword. It very specifically goes in the signature of our classes, goes in the signature of our methods, but in this particular case, it just means that it is unfinished. All right, lots of details. We haven't talked about casting in a while, so that's what's different and what we are going to have to be careful with, very careful with, when we look at all the polymorphic capabilities that Java has. That's it. Bye.